All right, hello, hello. All right. So I have to wait for YouTube to give me the okay that things are streaming, that this is being recorded. Um, all right, good. YouTube gave me the okay. OMG. Hi, everybody. I'm Mr. Salt, and this is the third time I'm doing this recording. All right. The first time I recorded this, um, it recorded everything fine, but it didn't record my audio. So the whole video is me just moving, gesturing with my hands and gesturing and oh yeah, no audio. So okay, so then I was like, you know what? For you guys, I'm gonna do it a second. I'm gonna take two. Take two. Do it again. All right. So spend another 45 minutes of my life redoing the recording. That time the audio was recording, but it wasn't. I didn't check the live stream to make sure it was going to the live stream, and so it didn't record. It's just gone. It's an hour and 50 minutes of my life just disappeared. As you might imagine, sorry for all this. I just want to commiserate, right? I want you to feel my pain. I want you to feel my pain because I understand that maybe it might be painful for you to get through these. So, yeah. So I got frustrated last night and I decided I'll do this. I'll do it later. And so I'm doing it now in the morning. How you doing? Hope you're having a good day. I'm doing okay. So let's do this. This is number 9. This is number 9 that we're gonna do today. All right. Sorry for that. It's morning time, so the sun is in my face a little bit. All right. There we go. So we're gonna go. So in class, we asked you what kind of cat you're feeling. What am I kind of feeling right now? I think I'm back to 6. I was 8 after it didn't record the audio and the video. Maybe even a 2. But I'm a 6 again. It's morning. I'm over it. I just now that I got that off my chest. Thanks for listening for that. Okay. Learning targets. Learning targets. I'll read these. Right. So by the end of this lesson, we've got some very complex learning targets here for you. All right. You should be able to say, I can calculate or select the appropriate measure of central tendency, mean, median, or mode of a set of data given or represented on a table, line plot, or stem and leaf plot. We're not going to really deal with line plots and stem and leaf plots at this time, and not really tables really at this time. Just but mean, median, and mode. Okay. We're also, you could also say, I can calculate or interpret the range, quartiles, and interquartile range of the data. If you still are not sure what interquartile range is, that's okay. We'll go over it. That's cool. These are where we're going to get you to. All right, we're going to get you there. And then I can describe how outliers affect the measure of central tendency. All right. So I forgot my little blurb. Um, I'm creating these videos. Yeah, why are we even here? I'm creating these videos for those students who may have missed class, who need to do this asynchronously, who maybe during class time wasn't the best learning environment. Maybe they can find a quiet space or quiet time sometime other in the day. So this is what these are here for. Sometimes students, just need us to slow down in class. Well, the great thing about a YouTube video is you can slow down the speed of the speaker, which is really good in my case because as you know, I speak sort of fast, right? I can try to slow down, but it is painful for me to put spaces in between my words. All right. So but you can slow me down, so I'm speaking a little bit slowly. Or if you want, you could speed me up and I'll start talking like a chipmunk, right? Talking even faster. You can also pause, and that's an important thing, right? Sometimes the teacher moves on before you can even get to where what the teacher was doing, and that's less than ideal. Well, the great thing about a video is you can pause it. Also, if you don't need a piece of the video, you can also skip forward, skip ahead, skip to the part where you need what you get what you need. All right. So I want you to control this experience. I want you to control this experience. Um, YouTube's giving me an error report. Okay. Okay, it's telling me there won't be smooth streaming. Sorry about that. Don't know how to fix this. Okay. The sun is in my eyes. All right, let's just review the measures of central tendency. So far in class, we've been looking at 3 measures of central tendency, the big 3. And I apologize because they all start with M, right? And then 2 of them start with ME. And students get these confused all the time. And it takes a little while to get comfortable with these terms. And so just stick with us. And after you've heard it 100 times the right way, and you've practiced it 100 times the right way, it'll be like, oh, that's nothing. But until then, just like learning an instrument or learning a language, it's awkward at first, right? You're not very good at it, and but that's all right because the learning happens in the struggle. That's not just an aphorism. That's not just rhetoric. That's like the brain science. Learning happens best when we're struggling. So if you're struggling, just know you're learning a lot, okay? If that makes you feel any better. All right, the mean. The mean is the average. And we want you to remember that the mean is the average by a little phrase, a little memory mnemonic, right? The mean teacher takes your average, okay? That mean teacher takes your average. So the mean is the average value of all the data. To find the mean, add up all the values together and divide by the sum of the number of values in the data. So to find the average, to find the mean, you add up all your numbers, add them all up, and then divide by the number of values, the number of numbers in your data set. Okay, add everything up, divide by how many things there are. That's the mean, that's the average. All right. Then we have here the median, And I think the best way to remember this is that that little strip of ever driven down a road and there's like two lanes of traffic, one going each way, but in the middle of that road is like a curb and a little strip of grass and maybe some small trees or something. Well, that little middle thing in between the two lanes of traffic is called the median. That's that middle thing. Gosh, I'm tempted to go Google it. How about you Google median in the road or something like that? Go Google that and take a couple pictures of what the median looks like on a road. And so yeah, median is in the middle. It's in between the two lanes of traffic, right? The median in statistics is the middle number in a set of values arranged from least to greatest. So if we arrange a data set from least to greatest, and then we take away the biggest value, and then take away the smallest value, and then take away the next biggest value, and the next smallest value. And we keep doing that, taking away the biggest, take away the smallest, take away the biggest, take away the smallest, until eventually we're going to come to either two numbers in the middle or one number in the middle, right? There's only going to be one or two numbers left after we get rid of all our other numbers. Well, that one number is the median. If you have two numbers, you got to add them up and divide by 2 because there's two of them. You're essentially going to take the average of the two numbers in the middle in order to find the median. And another unfortunate thing about this is, right, we're essentially taking an average in some median problems, right? Which confuses students because didn't you tell me the mean is the average? Yeah, well, we're going to take the average between two middle numbers to find the median as well. All right, okay. Sorry for that. I didn't make up these words. We just got to deal with them as they are. Last but not least, it's the mode, okay? The mode, we want you to associate the mode with the most. The mode with the most. They both start with MO, okay? So maybe that helps. The mode with the most. The mode is the number that appears most often in a set of data. Sometimes a data set will have no mode, right? If no number appears more often or more frequently than any other number in a set of data, guess what? There's no mode. If you can also have two modes, right? Two numbers could appear 5 times, which is more than any other number. You could have 3 modes, 4 modes. It becomes less likely, but it can happen. It certainly can happen. So just be aware there can be no mode, there can be 1 mode, there can be 2 modes. All right. Example 1. Now here's one of these things where maybe you don't need me to read this to you. I'm going to read this out loud, and I'm going to talk about this slide for those students who learn better when they can just listen to someone talk and kind of focus on that audio. If you don't need the things, you can just skip ahead, okay? Example 1. Find the measures of central tendency for the following temperatures: 34, 26, 47, 12, 18, 22, 50, 37, 32, 23, 34. All right. To find the mean, we're going to first add the values, right? We took all these numbers in this box, in this data set. We're going to add them all up. When we add them all up, we get 335. That's the sum. The sum is the result of addition, right? The sum is the result of addition. So we add them all up, we find the sum. Then we're going to divide by the total number of values, 11. Why 11? Because there's 11 numbers here. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, there's 11 numbers in the data set. That's why we're dividing by 11 here. All right, so we add all the numbers up, find the sum, divide that sum by how many numbers there are in the data set. If we put this in our calculator, we'll find that the answer, the result, the quotient, right, of this is 30.45. 30.45 is the mean. It's the average. Okay? We have found the mean. The median's a little different, right? We find that median a little differently. We find the median by reordering the data from least to greatest. So here, these numbers here are the same numbers that are up here. They're just reordered from least to greatest, right? This 12 went out front. This biggest number 50 went in the back, and they reordered all this data in order from least to greatest. And then they started to find the median. They started eliminating the biggest and the smallest numbers until they arrived in the middle, right? So eliminate the 12, get rid of the 50, get rid of the 18, get rid of the 47, get rid of the 22, get rid of the 37, get rid of the 23, get rid of the 34, get rid of the 26, get rid of the 34. I'm left with one number in the middle, therefore that's my median. That's my median. Okay? Sorry for the sun glaring in my face. You didn't want to look at me anyway. So anyway, so 32 is the median. 32 is the median. So you locate the number in the middle. If there happen to have been two numbers in the middle, and that'll happen whenever the data set has an even number of numbers, right? If there's like 20 numbers or 22 numbers, you're going to end up with two numbers in the middle. If it's an odd number of numbers, like 11, you'll end up with one number in the middle. When there's one number in the middle, your life is easy. That's the median. When there's two numbers in the middle, add them together and divide by 2. All right? To find the mode, we're going to find the value that occurs the most often. If there are two or more values have the highest frequency, then record both values. The mode for this data set is 34. Why 34? Well, notice here that 34 shows up twice, right? 34 shows up here, 34 shows up there. So it shows up twice. No other number repeats twice or more. Therefore, 34 is the mode. All right? So that is mean, median, and mode. Hopefully, you're feeling just a tiny bit better about mean, median, mode if you didn't already have this solid. But we're got a lot more slides to go through. So you'll get better and better as we go through this, right? All right, so now we want to talk about quartiles. Quartiles throw students off every year. It takes a little while to wrap your brain around this, but you can do it, and it's no biggie. Pardon me, I might have to cough. Sorry, it's not a good way to close my audio. Maybe I could close my audio. All right, I'll do that next time. I don't want to cough at you. Alrighty, quartiles and interquartile range. The word quartile is a fancy name for dividing the data into 4 equal parts. To find a quartile, find the median, and then find the median of each half of the data. All right, and then we're going to talk about the interquartile range. The interquartile range is the difference between the first and third quartiles. The diagram below represents ordered data separated into quartiles. Okay, so if this was our data, right, if this box was our data, this over here would be our smallest number, or our min, our minimum, okay? This over here would be our biggest value, or our max, all right, our maximum value. So we got our minimum value over here, minimum value. We got our maximum value over here. Then once we have our data arranged from least to greatest, from min to max, we would then find the median, right? We'd eliminate numbers until we found that middle number. And so right, this right here is the median. Oop, I got it. I can do this. Maybe make that D a little better. Oh, it's ugly. It's ugly, but you can read it. Don't give me don't give me a hard time. So median. So kind of like, so if we were, so now we've basically divided our data in half. We've divided our data in half, and this is our median. It's that middle number of our data. But if we were then to change and look at that first half, just the first half by itself. I normally hate the highlighter, but maybe I will go with the highlighter this time. If we just, oh, I don't like the highlighter. Nope. It's too slow. See how that moves so slow? I want to undo what I just did. I don't know why this is. Come on, you can do it. All right, I'm going to go back to that pen. I want to change colors. I'll go green. All right, so this is the first part of my data, okay? So this is the first half of my data. Notice how the median cuts my data in half. I got the lower half over here in green. I got the lower half over here in green. And Then let's do purple over here. Okay. Oh, no, I already did purple. Gotta pick a new color. Orange. How about orange? All right. All right. This is the second half of my data. This is the second half of my data here in orange. And if I look at these two halves independently, I could talk about, well, couldn't I cut this half in half, right? If I cut this half in half, I'll find what we'll call eventually quartile 3, right? If I cut the half of that half in half, I'll get the third quartile. If I cut the first half in half, I'll find quartile 1. And notice how, when I do this, I've now cut my data into 4 equal parts, right? 1, 2, 3, 4, right? The median cuts everything in half, and quartile 1 cuts the first half in half, right? And then the quartile 3 cuts the second half in half, right? So quartile 1, quartile 2, otherwise known as the median, quartile 3. See how that kind of works? With our minimum and our maximum being on the outsides containing our data. Hopefully that makes sense why we call it a quartile, like a quarter, right? Like a quarter, there's 4 quarters in a dollar. These are quartiles. They're 4 equal parts of the data. And let's talk about the interquartile range. The interquartile range. Well, do you remember what the range is? Yeah, Brown. The range is all this, right? The range is max minus min, okay, equals range. The range is the difference between the maximum number and the smallest number. We take the maximum, we subtract the minimum, and we find the range. It gives us an idea of how dispersed the data is, or how spread out the data is. Well, interquartile range is kind of similar, because interquartile range is quartile 1 to quartile 3. Just this little piece. And how do you find the interquartile range? We call it the IQR, interquartile range. You find that by quartile 3. Don't make fun of my 3 now. Take the quartile 3 and subtract quartile 1, right? Range is max minus min. IQR, or interquartile range, is Q3 minus Q1. It's the difference between the Q3 and the Q1 is the interquartile range. All right? Hopefully that makes you feel better about the IQR and the range and the quartiles. That's all right. We got more to learn. Again, if you don't need all this, you can just skip ahead. Go right to the problems, right? So, measures of central tendencies and quartiles. Example 2. Find the interquartile range of the following data. 12, 17, 34, 56, 32, 23, 83, 31, 9, and 36. All right. To find the interquartile range, we'll first need to find the median, which means we first need to find each quartile by rearranging the numbers from least to greatest. So notice that all these numbers here are the same numbers we have over here, except now they're arranged from least to greatest. All right. They made our life a little easier for us. And we're going to find the median, right? So we're going to find the median. We're going to get rid of the smallest number, get rid of the biggest number, get rid of the smallest number, get rid of the biggest numbers. Now, I don't have to do this one at a time. I can get rid of the next 2 smallest numbers, right? And that means I have to get rid of the next 2 biggest numbers. Oh, but once I do that, I find that I'm left with just 2 numbers in the middle. Remember what you do when there's 2 numbers in the middle when you're trying to find the median? You take their average, right? You add them up, divide by 2 because there's 2 of them. And we found that the median here, the median is 31.5. That's the number directly in between 31 and 32. All right. I won't use the eraser here. I'm just going to erase everything I've got. Okay, so notice how when I find the median, if the median is right here in between, 31 and 32, that the median has cut my data into 2 halves. Okay? And now to find quartile 1 and quartile 2, I'm going to look at those halves independently, right? There's the first half. There's the second half. To find quartile 1, I want to find the middle number. I want to find out what the middle number is of this? Well, you can kind of see it's already 17, right? There's a great giant arrow pointing at it. But see, cross out the lowest, cross out the highest, cross out the lowest, cross out the highest. 17 is that middle number. That's quartile 1. That's Q1. And then cross out the, you already see it, cross out the highest, cross out the lowest, cross out the highest, cross out the lowest. That middle number in the second half of the data set is quartile 3. Now to find interquartile range, so if I know that the quartile 1 is 17, quartile 3 is 36, to find the interquartile range, I'm going to take 36, I'm going to subtract 17. I find that the difference between 36 and 17 is 19, so the IQR is 19. The interquartile range is 19. That's the difference between how far apart quartile 3 and quartile 1 are. Hopefully that is, you're now feeling a little bit less, like interquartile range is a little bit less of a mystery, right? All right, now you'll notice that in this box, stuff is written. I didn't write this stuff. This is the stuff we already have in class. In fact, you have access to this document that I'm looking at. All the notes that we went over in this class are still here. So, for some of you who haven't taken a look, you could have, if you just take a look at this document, you've got this, okay? So hopefully you get this number 9 assignment in. So, answer the following questions. Explain how to use the median to find the quartiles. Well, first we find the median of all the data numbers. Then we found the median of the lower half and the median of the upper half, right? You can think of quartile 1 as the median of the first half of the data, and quartile 3 as the median of the second half of the data. They're the middle numbers of the first half and the middle numbers of the second half, respectively. And then the interquartile range, we found that by Q3 minus Q1. That's the interquartile range. That's how we might describe all that, all right? Next slide. All right, find the mean, median, and mode of the following data sets. The size in centimeters of random perch, that's a fish, caught in Lake Erie, okay? Ever caught a perch? They're kind of fun. Yeah. All right, so we got 12 centimeters. Man, these perch are not very big. Okay, well, this one is 30 inches, 30 centimeters. That's pretty good. All right, 12 centimeters, 8 centimeters, 7, 10, 6, 30, 23, 26, 18, 23, 14. Okay, that's our data set. So we're now going to calculate the median, all right? Well, we add all these up, and in class we found that the sum was 177. And then we counted there was 11 perch, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to take the sum, 177, by adding all these up, divide it by 11 because there's 11 perch caught. So 177 divided by 11 is 16.09. That's the mean. That's the average. All right. The average size of the perch caught was 16 centimeters. 16 centimeters was the average size of a perch caught. Now we're going to find the median. Well, to find the median, we're going to need to rearrange the data. So we rearranged the data in class here. And we got rid of the lowest 5 numbers, right? We got rid of these lowest 5 numbers. Then we got rid of the highest 5 numbers. And we found that 14 was right in the middle. 14 was left over. So guess what? 14 is our median. It's our middle number. And then the mode. The mode is 23 because we see that 23 repeats twice. No other number repeats at all. So 23 is our mode. Okay? By now, this is almost either start getting pretty good in your head, like, oh yeah, or probably boring. That's where maybe I'd expect you to be, where you're to be right now. But let's do another one, right? All right, I'm gonna call out a football play, right? 14, 22, 18, 21, 14, 35, 42, 42, 21, 14. I played football in high school, and I never knew what any of those plays meant. The points scored by a football team during each game last season were, and I already said them, right? We're going to calculate the mean, median, and mode. The mean we found out, well, when we add all, we find the mean by adding everything up and dividing by how many there are. Well, when we add everything up, we find we get 242. We found that there was 10 numbers here. 242 divided by 10 is 24.2. 24.2 is the mean. It's the average. It's the average number of points scored by a football team during each game, right? So on average, they scored 24.2 points. To find the median, we had to rearrange our data. So here's our data down here, rearranged. And, if I start eliminating, oh, I don't want the highlighter. That'll be, all right, if I get rid of say I get rid of the top three, right? I get rid of these three numbers. Then I get rid of these three numbers. And then I get rid of this number here, and I get rid of that number there, and then I'm left with two 21s in the middle. I'm left with two 21s in the middle. So I add them up, I get 42. I divide 42 by 2, and I get 21 again, right? Hopefully you already knew that you knew the median was going to be 21. All right. And then the mode. Last but not least, the mode. Well, I see that 14 and 21 both repeat 3 times. No other number repeats that many times. So we have 2 modes in this data set. 14 and 21 are our mode in this data set. All right. And again, you can always skip ahead if you don't need these explained. Use data provided to answer the questions below. Here's our data set. I won't read all that out. Right? Write the data in order from least to greatest. So in class, we reordered this from least to greatest. This is reordering the data takes a while. That's where I make my mistakes. So you got to do it really slowly and carefully. So if this takes you a long time to rearrange the data, don't worry. That's kind of how it is even for me. So anyway, find the median of the data set. This value is known as quartile 2, or quartile or Q2 for short. Right? The median is technically called quartile 2. We usually just say the median. So we found, let's get rid of the top, let's see, 1, 2, 3, 4, 5, 6, 7. Let's get rid of the top 7 pieces of data, and then let's get rid of the lowest 7. 1, 2, 3, 4, 5, 6, 7. All right, so we get rid of all of these, and we're left with 11 in the middle. 11 is the number in the middle. After we get rid of the top 7 and the lowest 7, that means the median is 11, right? It's the middle number in the data set after I've eliminated my top numbers and my lowest numbers. To find the first quartile, I'm going to ignore the 11 that's the median. Because the 11 is the median, where is my pen? I hate that highlighter. I don't like it. It's too slow. Because the 11 is my median, I'm going to ignore it, right? It's not part of the first half of the data. It's kind of like once it gets found out to be the median, we just ignore that. It's one of the rules of finding the median. Yeah, since usually we do this on calculator by computer, even I have to remember do I include the median in this or don't I? You don't. Okay, so let's look at this data. We have 7 numbers in this data set. We've got 7 numbers, and if I eliminate the bottom 3, I eliminate the top 3. Look at that. 8 is in the middle of the first half of my data. Therefore, 8 is my quartile 1. And the same thing over here, right? I eliminate my bottom 3. I eliminate my top 3. I get 14 in the middle. 14 is my quartile 3. Okay? So you kind of feeling how that works now? You take the kind of the median of the median. That's quartiles 1 and 3. Right? And that gives you those 3 numbers. Okay, and then interquartile range is the difference between 14 and 8, right? It's what's 14 minus 8? Well, that's 6. So there's a difference of 6 between 14 and 8. So that's our interquartile range. Our interquartile range is 6, the difference between quartile 3 and quartile 1. All right, so here's our data set. It's all disordered. In class, we reordered it. Hopefully you can kind of see with the heart there that 64 becomes our median, right? We took away the top 4 pieces of data in the data set, took away the bottom 4, we ended up with 64 in the middle. That's quartile 2.
Breakfast is ready.
Sorry, I have a little public address system in my house. Apparently breakfast is ready. Let's see, quartile 1. So to find quartile 1, I'm going to look at just this data right here, right? I'm going to ignore the 64 because that was the median. I ignore the 64, and I see that in the middle, these 2 numbers are the middle of my first part of my data set, and then these 2 numbers are the middle of my second half of my data set. So I'm going to need to take the average between these two numbers to find quartile 1, right? So I take 43, add it to 55, divide that by 2, right? Add them up, divide by 2, 49. 49 is my Q1. Take the difference between 82 and 83. Sorry, 82 and add 82 with 83. Add them up, divide by 2. And you can kind of already see that the middle number between 82 and 83 would be 82.5. 82.5 is our third quartile, right? 82.5 is the Q3. And interquartile range. Hopefully by now you already know you're going to take the quartile 3 and subtract the quartile 1 to find the interquartile range. Okay, I'm hoping you're bored by now. That means the learning is done. That means you got this. Okay, and right now normally in class we take a little brain break before pushing on and doing the next problem. I'm actually not going to do this problem. This is the one slide I'm not going to go over in this video because, you know, math is heavily skill-based, all right? The stuff you're learning is heavily skill-based. If you don't practice, you're not really learning. And if you're just kind of watching me, lift weights, you're not building your own math muscles. So while it's kind of, while it might feel comfortable to, in a supported environment to, have me do these, I want you to practice some on your own, right? That's going to be, this independent practice part is going to be important for your learning. Remember how I said the learning happens in struggle? That's not rhetoric. That's the brain science. You're actually learning more when you're struggling. And when things are easy, that's when and when you're bored, that's when your brain is tuned off. Your brain's no longer struggling. It's kind of bored, so mind starts to wander. You're learning a little bit less. So give this a shot. I'll talk about it. I'm not going to do it, all right? So this then says, answer the following questions using the information provided. pH is a scale used to determine the strength of acidity and alkalinity of liquids. The scale ranges from 0, being acidic, to 14, being very alkaline. In the middle of the scale is 7, which is neutral, neither acidic nor basic. The list below provides a pH of various liquids. So tap water is 7.6, vinegar is 2.8, milk is 6.5, battery acid is 1.0, ammonia is 12.2, lemon juice is 1.9, bottled water is 7.0. Whoa, okay, yeah, 7.0, that makes sense. Lye is 13.5, seawater is 8.3, stomach acid is 1.5, and Coca-Cola is 2.5. Here, you're going to determine the mean, median, and mode of the data. Now, we've been doing this a whole bunch, so I feel like you'll be able to handle this. If you don't remember how to find the mean, median, or mode, go back in the video and see some examples, right? You might have to put in a text box. Wait, is there already text boxes here for us? Okay, there's already text boxes here for us. Sorry, doesn't look like it's necessary. There, okay. There's already text boxes. 17 is determine the Q1 and the Q3 and the interquartile range, right? I've been talking about this ad infinitum, right? Hopefully this will be an easy layup for you. And then 18, determine the minimum, maximum, and range of the data. Remember, the minimum is the smallest number, the maximum is the biggest number, and the range is max minus min. All right, we've talked about all that. And it actually gives you that reminder there, okay? So you can rearrange your data in here. You can rearrange the data in this little box when you're trying to find that median. All right, I'm going to leave you to it. I will go over the next slide, though. Where do you find your Q1? The Q1 is between the median and the minimum, right? It's that middle number of the first half of the data. What's another name for Q2? Another name for Q2 is the median, right? It's the middle number of the whole data set. Where do you find the Q3? Well, it's between the median and the maximum, right? It's between the median and the maximum. That's where the Q3, it's the middle number of the second half of the data set. If you need this, pause. But I would like to thank you for watching. I hope these videos are of value to you. I'm going to, I'll see you in class, all right?